Okay, guys, so welcome to the fifth class of the Sweet Primer. Basically, the last things we will be covering is how to handle closures, blocks, and threads, and then concurrency, which actually try to solve a very similar thing. So last class, we actually touched a little bit of closures. So closures are no more than anonymous functions that you can use and pass as values for later usage by something else. So for example, in this case, we're passing a closure, which is literally just a block that returns something and doesn't have a name, so that this function uses it so that it can leverage this this statement to determine whether this will match our criteria of what we're looking for or not. So basically, the closures can actually serve any purpose you want. In this case, they're using it to match the first element, and we are determining here whether it's matching the same value or not. So that's what closures do specifically. We can actually see a very similar capability here. And we also touch a little bit of delegates. So delegates will allow us to, for example, execute a process and operation, and then eventually talk back to something else by using the wiki reference and deliver the elements that we want. So in this case, of course, this can serve any purpose. But actually, this specific usage is a little bit poor because we are just delivering a set of elements. So in this case, we should probably want to refactor this to use a closure instead. So what is happening here is we have a fetcher that we are creating by just a reference from the initializer, and then we are sending a delegate to it so that it can talk back to us. And eventually, we use this fetcher to start the operation of fetching the employees. But actually, it would be way more simple if we could just say, okay, run the operation of the fetcher, meaning fetch the employees, but then by using the closure, bring back to us the employees that you're getting, instead of having to create a completely separate function for handling the employees. In this case, we created the deliver function, but this actually would be better off with something as simple as this. Something that a closure that takes a set of return employees, not say return, but resolve employees. And then we can say, okay, our employees, we're going to append to this array the new employees. So let's call these new employees to differentiate. This is actually a way better way. So basically what we have right now is a closure that will handle the only operation that we need to execute later on whenever the employees are available. So this run will determine when they are available, and then just as we are seeing here, it's talking back to the delegate, but now it will use that closure to deliver the employees back to us. So in this case, of course, we will have to change the signature of this function, otherwise it won't work. Actually, I'm surprised it hasn't thrown any errors. Okay, let's see. This will take a closure that will return void, but will take a set of employees. And this function has actually a name called employees solver, for example. We don't have to pass any label. We can say no label, but this is the name of the function. Okay, so we have an unlabeled function called employees resolver that will take a closure as a value from the argument we pass to run. So that means we can actually go ahead now and say employees resolver. We pass the list of employees, the array. In this case, we can pass this exact same array. And and we don't have to talk back to a delegate anymore. So it's important to be able to differentiate when you guys want to use delegation, or maybe you can just handle everything by using the closure. It really depends on the life cycle of the application, the lifetime of the references, and of course, how many events back you want to handle at your original instance. In this case, we want to handle, in this case, we are gracefully handling only success. Of course, sometimes, most of the times, we should also handle errors. But if what you all want to handle is just success and error, a closure will do. If we want to handle progress and some other events, you may want to consider delegation. In this case, we don't need this delegate anymore because we're just using the closure right there. And that means we don't have to pass any delegate anymore. Meaning we don't need this function anymore because we are just passing the closure that is doing the job for us. Okay, so this is what closures are about, are anonymous functions that we can pass as arguments so that another function or whatever, even an instance, can use later on for whatever need we see fit necessary for our use cases. So in this case, we're using the employees resolver to deliver back to us an array of employees that we're fetching, and that's about it. Since we don't need anything else, we don't need a delegation or any other mechanism. So this is great, but we actually have more important things to solve here. So usually we have an operation that fetches employees, but this is actually meant to be an asynchronous operation. And an asynchronous operation is something that takes usually more than 200 milliseconds. And of course, in this case, we are literally creating a line as an employee, but usually what we do is fetch a REST endpoint, for example, or maybe a GraphQL service. So in this case, we're going to simulate, we need to do this in a completely different thread, because if we leave this like this, if we try to fetch the employees, say, fetched employees is this, and then deliver the fetched employees. Usually when we are resolving those employees, it would be an asynchronous operation, meaning we should take that to a different thread so that the UI is not blocked. So this is actually fairly common in native applications, so it's important to be able to handle them. So basically what we do is use something called the dispatch queue. The dispatch queue is a very important construct in the foundation library that will allow us to create different threads. We have direct access through a static function to something called main, which is a dispatch queue. And that main queue refers to the queue, the thread where the UI is running. So whatever we run on this thread will run against the same thread where the UI is running. So we want to run there only the operations where every process takes less than 200 milliseconds, because otherwise we'll be blocking the user interface thread, and hence we'll be providing a very poor experience to our users. In this case, since we want to take this to a different thread other than the main thread, we're going to say we want to go global, and we want to create a completely different thread. In this case, we want to pass the quality of service because we want to determine how important this operation is. Since this is actually something that will be very important for providing a proper user experience because we need to fetch the employees, we will say this is actually user initiated. We can also use background, user interactive, and they have different priorities. So the operating system will be able to determine when to stop a process or not, depending on the resources available and the priority of the operations that you have already started. In this case, we're going to use with user initiated, and this will take, will allow us to run something async, and we can pass a closure here to do whatever we need here. In this case, we're going to say these fetched employees are actually being fetched from a REST endpoint as an instance, and then we're going to take this to a global queue. Whenever we are ready to deliver this back to the UI, meaning calling this closure that we just took from the parameters, what we have to do is not call this on the exact same thread as the global we just created, but go back to the main thread because we need to pass this back to the UI. So what we have to do is, again, refer back to our dispatch queue, say main, and then async. And then we call our resolver and pass the affected employees that we just got here. So this is actually a very, very common use case of the different threads. You create a thread to run background operations that you don't want to be user interface blocking because, of course, they may be REST endpoints or maybe even a local database or something that maybe requires you interacting with the outer world. And then whenever you're ready to speak back to your UI, you go back to the main queue, and by just running async and passing a closure, you can call anything that will be then executed on the main thread. And this is it. This is what threads are about. This is the most simple use case. Of course, there are way more advanced capabilities of it. You can create your own dispatch queues. You can use different quality of services. You can pass even labels so that you can properly debug. In this case, actually, we could have, let's see how much it has changed. Yeah, you can pass a label here and say, okay, this is REST endpoint label, meaning you can actually use this here, and you can pass a quality of service. Yeah. And that's about it. You are creating a new dispatch queue that is not global, is not part of the global queues with your own label, and the quality of service will be determined. And then the only one that you will have to refer back to your user interface will always be main. So there will always be a single one thread that keeps your application alive and runs the UI, and that is called just main. And that's about it. That's for closures, blocks, and threads. Blocks are basically another name that closures take whenever you are using it to DC. So it's important for you to be able to determine, okay, a block is just a closure, it's just a different vocabulary. And basically, threads is the way Swift handles threads is by using queues. So every queue is a different thread, and this framework will give you the power to handle them as you see fit. There's another API for handling operations called the operation queue. That actually gives you some other capabilities so that you can actually connect dependencies across different queues. And something great about this API is the fact that you can have certain classes inherit from operation, and you can have them run a completely separate thread. So whenever you want to build something way more advanced and want to surround a piece of functionality around an operation that then you want to control later on with semaphores and be able to pause it and resume and many other features, you use this API called operation queue. So Foundation has a lot of things to offer. It's just we can't cover them all on this quick primer, but eventually later on we will be able to touch all these while we are developing certain apps. Okay, so let's jump back to let's go now to concurrency. So this is all great, and we are now using closures, which I'm sure you guys are very familiar with because closures are actually very common in other languages as well. But then there's another concept that is also common in other languages that will give you the chance to have your asynchronous operations be basically have a better syntax when it comes to be able to be treated as synchronous code, and that's called concurrency. But concurrency is actually a very open word because this is actually kind of concurrency. But concurrency refers to something that you guys need to be familiar with called async await. And async await is basically a couple of keywords that will allow you to treat certain asynchronous operations as if they were synchronous code. And basically, they provide a more syntactic sugar, an easier way to read your code. So instead of just having this run take a closure, we probably would expect to have a different function, so different signature. So let's go ahead and redesign a little bit this signature so that it complies to what we would probably expect from a function like this. We run an operation of the employee fetcher, and this actually returns a list of employees. And this is especially true because in this example, we're not really hitting any REST endpoints, hence we're not running any actual asynchronous operation. So we could just say we are returning this. Let's say return fetched employees. That's just fine, but we're assuming this is actually an asynchronous piece of code. So we want to assume we are hitting an actual endpoint. So this is actually not possible because it will be happening in a different thread, and then we will have to deliver these fetched employees back to the original caller of this function. So this is actually not possible in this case, which is the reason why this signature isn't possible, and hence we have to use the closure. But there's actually a way we can call asynchronous operations and have this function with this signature. And that is saying this is actually an asynchronous function. And that means whatever happens here will not hold to the main thread and will continue calling whatever is called after this. So whenever we are calling this function called run, whatever we do here, we just run fetcher operation. It's going to be called immediately after that. So right now we're using this closure-based function. Then it will not wait. It will just like start executing, continue, then print this. If we run this function like this, it will happen the exact same thing. It won't wait for us to get the employees. It will just open a different thread and continue whenever it sees fit. So basically, it will create a different context of execution so that it doesn't block the user interface. So in this case, what we're going to do is actually simulate a little bit of what any synchronous, a regular asynchronous function is like. So we're going to simulate we're hitting an endpoint. And then we're going to say, okay, we have an URL, which is an URL that takes a string. And then we're hitting an endpoint around. Say we have an endpoint like this. And then what we're going to do is call an asynchronous function that comes from something called your session. Your session is our target for dealing with HTTP network requests. So your session will allow us to access a shared configuration and call something called the data. And you guys can see there is one signature of data that is actually an async function, meaning we can just pass the URL and say we want to await. So this await is basically the other side of this concurrency feature. Await will tell us, okay, this is actually calling an async operation, meaning it may need to open a different thread. And since this function is already async, await is basically completely welcome here because we are saying we need to wait for this to continue executing. But it won't block the UI. It will operate a completely separate thread underneath. So in this case, we can actually rely on this and say, okay, our employees are be appended by the result of the execution of fetcher.run, the one that has a different signature that is async. So it is actually saying that change the name here real quick, async run, so that we can differentiate the different signatures. This is async, but this is just regular closure-based function. And call async run. Okay. And that's about it. We can just, instead of having this, we can say literally, okay, the result of this async operation is going to be an array of employees, and then we're going to append this back to our employees. And actually, yeah, this is good. Now let's go back to our function and let's make sure this actually works as expected. This is not returning the list of inline employees. We're going to say, okay, this actually has a result. It's data, and we don't care about the response. And we can encode this and say we have, let's say, actually there's a way to encode this. Let's see for a second. Okay, we can actually have a JSON folder. Sorry, yeah, the folder. And we can use the decoder to decode from a type. We can say we want a list of employees, and we want this to be based in from the original data. And the list of employees is a return of this function. So basically what we're doing here is we are calling the result by using the weight of this endpoint. Whatever is returned is going to be a set of data and a response. We don't care about the response, so that's why we put this placeholder here. Then data is just a type data, so we create a JSON decoder. The decoder will allow us to deserialize our original JSON data onto a list of employees. So this will happen because employee will need to be something called codable, otherwise it won't work. And then basically we have this list of employees that is an array of employees, and we are going to return it. And that way, we don't need to open a completely separate thread, because by just saying async, it will do the job for us. Then by using this decode, we transform the original JSON data to our array of employees. And then whenever we call this async run, it's going to actually return the list of employees we need, that we are then going to append to our original employees that we are using on our UI. And that's about it. That's the way you use concurrency. This is the most simple way. In this case, this is actually fairly incomplete because we're not even handling errors. Something great about using concurrency with async await is the fact that you can leverage the original capabilities of the do catch that we talked about in the last session. So we can say, okay, this is actually something that may fail, because this call can actually fail. So in this case, we will need to provide a try here. So we can say try await, because this will need to await because it's often a separate thread, but at the same time, this may throw. Hence, we're going to capture this error on this catch. Then we're going to print it to realize from that debugging experience that something happened. And then we're going to say, okay, we're going to return an empty array of employees because we couldn't fetch any employees. And that's about it. We are handling an error. This is not throwable because we are actually handling the error here. And then we are going to say the success path of this returns the list of employees that we actually promised. But in this case, if we fail, we just return nothing. We are complying to our original expectation here. And yeah, that's about it. That's what that's the way we handle operations for later execution. In this way, we are interacting with the REST endpoint. In this case, of course, we can translate this to a completely different operation, like let's say dealing with a database or downloading an image or running any expensive operation that you may need to run on your apps by not blocking your UI and letting just your user continue using your application. And then eventually you can go back to your UI and make the updates that you find necessary. In this case, we missed something important because whenever we run an await function, we need to say this is actually async as well. So we need to let this know that this is a function that will not block the UI. Otherwise, this won't make any sense. We created the async await function in order for it not to block the UI. So we need to say this actually is an async operation, async function that will be calling an await function. So it's important to realize this. And whenever we are calling the fetch employees, we need to make sure that this is actually an async function. And that's about it. That's what concurrency is about. That's the way we handle operations. And yeah, let me guys know if you have any questions.
So async await works here similarly to JavaScript.
It's very
In the
similar,
case,
actually. Yeah.
so
That,
in the case that when you use the wait, you use to wait, the thread is the thread which calls await is given is freed so that it can keep receiving signals from the user. Is that correct? It doesn't block it.
yeah, exactly, because it all opens a different thread underneath. Yeah, exactly. And that's where the concept of actors come in. So actors are actually a new data type that was introduced last 2 or 3 years that basically will allow you to handle operations in completely separate threads. So that's actually something we will talk about later on during app development. But yeah, this created the concept of actors in order for them to be able to run on completely separate threads and isolate those functionalities in separate cores of the processor. Yeah.
Okay, thank you.
Any other question? I mean, this actually, unless you guys are fairly familiar with concurrency, this may be a little bit tricky because it's really important to understand when to use async await and when not to use it. So this is actually the experience with the language and the features you want to write will let you know eventually when to use those. But yeah, this is actually a very important feature that was included recently in Swift, and this is just something great because you don't have to leverage on closures anymore, and we want to actually keep our functionality as clean as possible and not rely on closures all the time. So in this case, it's actually a little bit verbose. So we don't want this. We prefer this, especially for simple operations like a REST endpoint call. So, but sometimes you may want to execute concepts that are more advanced, and that's when the concept of streams and sequences and publishers come in. Those concepts we will be covering later on during this course. Okay, guys.
Okay, thank you.
Okay, so yeah, this is a wrap. So this is the end of the Swift primer. On the next class, we will be starting to use a little bit of UI kit to see how actually to run an app using all the Swift knowledge that we have collected so far. Thank you so much. We'll start recording.